Now, to finalize the CI/CD pipeline, we are going to look at this diagram. And of course, here I have some notes which are going to give you some ideas of all the tools that you are going to find in the CI/CD pipeline that we have just covered. As you can see here, we are starting with developers, and this is in the dev environment. Again, this goes back to the concept of DevOps. You can see here, developers are committing the code, and this is the source code or the code that is building the application. They are committing that one into the shared code base. This shared code base can be something like a GitHub, GitLab, Bitbucket, Azure DevOps. It's just a repository where the code is being held. Most of these repositories are usually online, and because they are online, you can access them from anywhere. For this commit to happen, there are things that need to be followed because this is a shared code base, and this shared code base contains important and quality verified code. So for a developer to be able to successfully merge the new code into this shared code base or shared repository, the developer must of course pass through a few steps. Such steps involve code review, and also there is permission that is granted maybe by the manager. And during the code review, of course, developers and other developers are able to review the code before it can be merged successfully into the quality and shared code base. Immediately that happened, we have, of course, Jenkins. We are considering this to be a Jenkins CI/CD pipeline because that is what we are familiar with. It doesn't mean that all CI/CD pipeline are going to be Jenkins. No, they can be different kind of tools. They are different kind of CI/CD servers. But Jenkins is one of the most famous. Now, after this code has been pushed to the shared code base, we do have Jenkins, and this Jenkins is integrated with Git and also integrated with this code base. So anything that happened here, we can automate the process of building the application or building or the entire CI/CD pipeline. And this can happen through two ways. We already saw that you can select the build trigger, which trigger the build after every 5 minutes, or we can do the POSCM. Anytime there is anybody who merge or commit, Jenkins, of course, go back and get the changes and scan the entire repository and start the whole process of building. Now, after that, we have, of course, integrated Jenkins with build automation tool. And in our case, we saw that the build automation tool is Maven. After the build automation tool, there are a few tests here we can run. For instance, we were running the static analysis test or the static analysis of the code test. And those analyses, we did them with SonarQube. Those analyses were to help, of course, to see whether our code is reliable, has bugs, is smelling, whether it has low maintenance, the technical debt on the code. Those are all things we could do. Then from there, we integrated our CI/CD pipeline with, of course, we can integrate this with JFrog, and JFrog is going to manage the artifacts. And if that is not the case, we can also, which is always the case, you should always have a way to manage your artifacts because they are building periodically. Now from there, we need to know exactly what is running in the production. In this case, if the production is running under containers, we went on and integrated Docker into our CI/CD pipeline. The reason we did so is because Docker itself is used to build images and also run containers. So here, by integrating Docker with in our CI/CD pipeline, we can now be able to build the image applications. After building the image application, we went through the process of tagging the image. We went through the process of logging into the Docker Hub. And of course, we went through the whole process of pushing the image application into the staging area of production. And here it is. In the staging area of production, after that, we have what we call the quality assurance. In the quality assurance, we have what we call a release pipeline here. And in this release pipeline, we have the QA here. Of course, QA can be here. Of course, they are just doing the quality assurance, and they are checking exactly whether this software works as it should. They are checking whether we need to harden the software. They are checking to see whether the integration testing work, unit testing work. They are looking at all those tests to see how this software is able to respond. They're also looking at the capability of this software to handle the traffic. Can it handle the traffic that is coming from the user, or is going to just collapse at a higher traffic flow? So those are the things they are looking into. And then, of course, they'll harden the server. It means that they're going to harden. They are going to look at the ports that are open. They are going to put some kind of security measures and all that. And then after that, if everything goes well, it's going to be deployed to the production. In the production, we can deploy it in Kubernetes, which is becoming very famous, especially because it's very good in the container orchestration. Then from there, the work is not done. We still need to monitor this application. And this is where you can use a CloudWatch, and you can use other monitoring tools to monitor this application as it runs in the production. So that's a good diagram. I thought is really going to help. Now here I want us to start to kind of have an idea of how our pipeline looks like and how our pipeline flows. We always start with the planning stage. We cannot just jump into the pipeline like that. We always start with the planning stage where we define the project requirement and also plan for the development task, because, hey, we are building a software. This software we need to know, is it being written in Java? Is it being written, do we have JavaScript? Is it enterprise application? We need to have an idea of what it is. Of course, when we have an idea, we can now be able to plan the best kind of CI/CD pipeline that we are going to use. In this stage, of course, you are sitting down with your fellow DevOps engineers and other fellow people, and you are looking into what kind of CI/CD pipeline you are going to come up with. When you are looking at what kind of CI/CD pipeline you are going to come up with, you are thinking about the kind of code that is going to be used. You're also thinking about the tools that you are going to use. And do you need to use Marvin? Do you need to use Gradle? Do you need to use Ant? Do you need to use Git? You are coming up, because this is the planning stage. You want to make sure that your plan is good and sound, so that when we start the whole process of automating the SDLC processes, we are not going to start like as if we are planning. So we want to get the planning stage well and good. Another thing you do in this planning stage, of course, is that you do go back and look at the previous project that you have done. And this is what we call the previous retrospective notes. And in the retrospective note, you are looking to see exactly what you did well and what you need to improve in. If there are areas that you did well, you want to continue to do that in the coming projects. If there are areas that you saw that you did not do well, now in the retrospective, looking at the retrospective notes, this is the time you need to look at those areas that you did not do well and come up with a better strategy to perform well in this coming project. So planning stage is very vital. And of course, there are tools we use here. And I just want to talk about a few things you can do. For instance, when we are writing the retrospective notes, which usually happen after the meeting is over, not meeting, but the project is over, we have a few things here that we usually use to write our notes. For instance, in our company, we can use Confluence. And we have Jira here, Jira Kanban. Confluence is also in the same Atlassian company. We use it for documentation. So we can document all the retrospective decision-making meeting, war room situation, so that we can always be able to go back there and look at those notes and again look at the areas we need to work on. So it's very important to remember that you use Confluence. It's not just Confluence. You can use any other tools, of course, for documentation, but Confluence is very famous. Don't confuse Jira Kanban and Confluence. Confluence is for documentation. Jira Kanban is for ticket management. Not just ticket management, we can also use Jira Kanban for bugs fixing and also for other things like testing, and also to be able to plan for the project and be able to know exactly how to carry out the project. Now, after that, we move to the next one. Here we have planned this, development work has started. So we have to create a GitHub repository. And this repository that we create is going to store the quality code that has passed the code review process. We already saw when we were dealing with the Git branches and the Git strategies that you do have to carry out the code review. The code review is important because this gives your colleagues an opportunity to review your code and also find whether there are errors in the code. This process is usually a good teamwork, opportunity, and it can help the team, of course, to improve the quality of the code. This is why the code review is very vital. Now, of course, here developers, immediately this repository is done, and of course we have protected the repository and we have required everybody before they can be able to successfully push the code into this new repository. They need, of course, to pass through all the code review and also pass through some permission, and then when they can always commit the code and the changes into this repository. So that's very important. That's something else you need to know. And this is why you have to understand the Git branching strategies, because if you don't understand the Git branching strategies, you don't understand how Git works. You don't understand the branching of Git. You don't understand the naming convention. It's going to be very difficult for you to be able to successfully carry out this second stage. The third stage, then we come to the Git, because now we have put the quality code inside the GitHub repository. It's not a must to be GitHub. It can be Bitbucket, can be Azure DevOps, can be GitLab. It's not a must to be GitHub. It's as far as the version control system online, we can use any. Now from there, we need, of course, you have to remember also, this version control system, they are storing the Git repository. So now we need the Git, of course, which is a software that is going to help us to clone the Git repository in the GitHub or any other version control system. For this process to happen automatically, we need to integrate Git and Jenkins together. Now we move to the next one. Now we have Jenkins, which starts at the middle of everything. Jenkins, of course, is a CI/CD server. Some people like to call it continuous integration server. It is going to help us, of course, to automate the process of cloning the code, because we are going to integrate it with Git. We are also going to integrate it with other tools. And the most famous tool that is very, very important in the CI/CD pipeline is what we call Maven. Maven is important because when integrated with Jenkins, it's able to automate the entire process of building or build automation. It's also able to enhance continuous integration. We saw that with Jenkins, you can trigger the builds. We also saw that when you have the Maven, of course, you can build artifacts, and those artifacts can continue to the rest of the CI/CD pipeline. Now we have another tool. This is Maven. Now we are integrating with Jenkins. And this is very important because we are using it to build the application. It's from this point of the CI/CD pipeline stage whereby we are converting the source code into binary code. And that's very important because it helps us to prepare for the next tools, because the next tools are not going to be understanding source code. They need to understand the artifact in the form of either .jar, which is what we saw .jar. Then after that, we need to pass that artifact to the SonarQube. Again, another tool we integrated with Jenkins. SonarQube is good because it's going to carry the code quality and static code analysis. It's going to help us analyze the code for bugs, vulnerabilities, and code smells. It's going to provide us with feedback on how quality the code is. Does this code has a high maintainability? Does it have a huge technical debt? Is it reliable? Is it a code that is secure? Because if the code is not reliable, it's not secure, has many bugs, we are going to build a software that is not of high quality. So this is another very important stage. Now we move to the next stage, which is JFrog. The JFrog here is an artifactory. Artifact, the work is just to manage the artifacts that are coming from the build automation stage. In this case, we saw that in our build automation stage, we are building .jar. These are the artifacts that are being produced by the build process. And also we have to remember that it's going to act as a central repository for managing our artifact. Why do we need to manage artifact? We need to manage artifact because the builds are going to be happening periodically. We also have Ansible. Again, this is also another tool that is integrated with our Jenkins. It's not difficult to integrate it. You just need to go and, of course, download the plugin for Ansible and then go put the location of Ansible. If you go on your server, and I'm going to show you here. If I come here and I say clear, if I say Ansible, I'm going to see the location of Ansible. So with this one, you just need to take this location and you go and integrate this Ansible with Jenkins. All right, so now why do we need to use Ansible? Ansible is the king of configuration. Sometimes people like to call it an orchestration tool, but you have to be specific with that word. Orchestration tool for what? It's actually for servers. It's not to orchestrate containers. That's the work of Kubernetes. So it's helping us, of course, to manage the setup and configuration. If you want to configure Jenkins, install Maven, configure SonarQube, configure JFrog, and other CI/CD servers, then of course we do need to have a configuration tool because it can help us to configure the servers quickly. It will also help us, of course, to ensure that all the servers are configured with the same kind of applications and environment. And that's very good because it helps us to be consistent and also be able to create an environment that is reproducible. Then, of course, we went on to integrate Docker with Jenkins. And now our CI/CD pipeline is growing bigger and bigger. Why do we need Docker? It's a containerization platform. What is containerization? Is that process of running multiple containers in a server. Why do we need Docker? Because we need to build, we need to run containers, and we need to ship containers on consistency basis. Finally, we were able, of course, to build image, tag image, log into Docker Hub, and now we were able to push this image application to the staging area of production. In this staging area of production, we are going to be using Docker Hub repository to store images that are considered the staging area of production. After successful build and test, Docker images are pushed to Docker Hub. Finally, if everything goes well in the staging area of production, QA is done, everything is fine, everything has passed, we are going to go to the live production, or what we call production environment. The Docker images from the Docker Hub are now deployed into the live production, which means nothing, but now they can be accessed by the customers. So far, so good. Now we go to the last one. With the addition of JFrog, of course, we saw that. Now I want you to pay attention to this one because it's going to show us a little bit of information. I haven't talked up to this point what continuous integration is. I haven't talked to this point what continuous delivery is. And I haven't talked to this up to this point what continuous deployment is. And I feel very strongly that this is the point I should introduce these key terms. We look at the application code. We already know that this is happening in the dev. We see that we have a source that is cloning that application code, then is going through the build process, unit testing, integration testing, is going to deployment. We have staging, we have QA and production. So what is continuous integration? Continuous integration is that process of writing the code. You write the code, you push the code goes through the build process, is tested. If it doesn't pass, again, you start all over again. That continuous process of mixing the new and the old code so that you can make a successful build is what we call continuous integration. What is continuous delivery? Continuous delivery is that process of delivering the image that we have built, the image application. You are delivering that to the staging area of production, and that is what we call continuous delivery. Continuous deployment, on the other hand, is that process. Of course, immediately the image go to the staging area of production, quality assurance is done, everything is fine, it is hardened, security is double checked, everything is working as it should. Then we deploy to the final customer, and that process of deploying from the staging area to the live production is what we call continuous deployment. I just want to touch a point here. Continuous deployment is not something that is recommended by many companies. So it's something some companies do, most don't. And here is our CI/CD pipeline stages. Of course, there are some stages missing, like SonarQube and JFrog, but these are just to help you, of course, to understand our CI/CD pipeline. And this is exactly how our CI/CD pipeline looks like. These are the stages. These are the tools that we have. What you need is to go through all these tools and understand what they are doing in our CI/CD pipeline. Thank you.